You are listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson of Proteum Machining, and this week I am very happy to welcome Joseph Pizzoferrato of Heidenhain. How's it going, Joe?
Very good. Thank you, Dylan, for having me. I appreciate it. This is my first ever podcast. I've listened to you a little bit, and also the Business of Machining podcast. So, yeah, it's an honor to be on here and talk about manufacturing.
Yeah, thanks so much. So, I introduced you, but give us who you are and what you do. I think that some people have met you. I know that when I put out Quiffer questions, people are like, "Oh, I know Joe." So, yeah, who are you and what you do?
So I am. So first off, of course, Joseph Pizzoferrato. I have worked at Heidenhain for about 8 years now, coming into 8 years here in April, and I started off in machining, actually at a called Durabar Metal Services out in Woodstock, Illinois. I grew up in Woodstock here, about an hour from Schaumburg, and I was just to cut off a saw blade, and they would just process a Durabar, and they're one of the leaders in cast iron. So I just started there cutting, working weekends and working. I had an internship there when I was in college. So I spent about 3 years with them, and I graduated from college in 2009 with a ME degree and also a minor in math, because I only needed one more course to get the math minor. It was a very difficult course, though. It was it was partial differential equations, so pretty involved with different diffie-q, and all I remember was spending about 15 to 20 hours a week just on that class.
Oof. Yeah, I never took partial, but I took diffie-q a couple times because it was not that easy.
I took it a couple times too. I took it once. I didn't jive the professor. I just had a difficult time. And then the second time I had a fantastic professor. What he taught us was actually on the test, and his notes were fantastic. So my background was in engineering, the mechanical side, and I was really fascinated by machines. Like my senior year, I didn't know if I was going to be a design engineer. Of course, I went through a lot of this design classes, but I was very curious and fascinated by machines and like how they moved, and just how would it cut apart? How did it find where the part was in the machine? I just found that very fascinating. I did take a controls class as well in college, so that was pretty neat. Now I work at a controls company, like I work in a controls division, so it's like full circle. So I sometimes see stuff like, that I learned in that class, which is pretty neat.
That's really cool.
Yeah, I just started at Durabar, and then from there I worked for a circular saw blade cutoff, so like a cold saw cutoff company called Kinkelder. They're out in plug out to them. They're in Rockford. They make great circular cutoff saws for like band saws, or not band saws, but for cold saws.
Okay, yeah, that's
so.
Really
I spent a few years with them, and then I was able to get into Mazak's application engineer training program.
So how did you find something like that? Like, as someone who had only worked on the fringes of machine tools, how did you find the job listing in the first place? And then what made you apply to something like that versus, it sounded like you were kind of in this track of like saws, and like I could very much see you like, oh, Kalamazoo or like any of these other big saw manufacturers. But what made you apply for that job?
I was searching. So I was searching on websites at the time. This was 2010, 11. So I was just searching around on DMG. I was searching all over, probably on Indeed, and I ran across Mazak. I looked at them, and I saw that they had a training program for like application engineers, and I applied with them, and I had a couple of interviews, and I got hired, and I ended up going through a 6-month training program in Kentucky. So where their headquarters is, in Florence, Kentucky. And that was fantastic for somebody that had never touched the CNC machine. All they had touched was cold saws. So I got a chance to see how they design the machine, how they scrape the castings, and how they put the machines together. So I spent time in manufacturing. I spent time with applications. I spent time leveling machines. I spent time with CAM. I spent time with tool manufacturers for a week at a time. So they gave us a taste of like their entire business model and all the different aspects of running these expensive machines.
So up until that point, you had never programmed a machine, though. You had not really been a machinist.
No, I was not a machinist. No, I just knew a little bit about like chip load, feed rate, RPM. No, now there were guys in there that knew machining. So there were tenured guys in there that had been machining 5-10 years. So they were, the head of the pack.
So how did they approach teaching you those things? Because like as an apps guy, you have like a lot of the weight of the company on your shoulders. People call you out to solve problems, and I would imagine they have to teach you very well, because like you can't go out to a customer and be like, oh, I've never heard of that. Like you have to be the source of truth.
Yeah, I got exposed to how they program. So I learned Mazatrol, and I think we did some demo parts. I don't really, I remember there being some jobs here and there, and we would watch and we would try. So like they always had machines at the tech center for us to play with. But of course, if you're really new, you don't understand even the dangers of like crashing the machine. Like you don't understand rapids, feed rates, keep things down. So we didn't have a lot of hands on there like in the shop, but we got exposed to a lot of the aspects of how to be like how to understand the code, how to understand the control. And from there we were able to build and go through this program. I just remember there being just modules upon modules that we had to do, like 1 week with Kennametal, learn about Kennametal tools, 1 week with Sandvik, 1 week with like how they manage their tools with their cyber tech stuff. So I learned just all the aspects of like how they run their controls, and I learned Mazatrol. So I learned 2D machining, and I went through those classes and spent time on the control. And then what happens when it was over in 6 months, we all went back to our respective regions. So we all came there. They put us up in apartments. And so we all stayed there for 6 months. And then after that, and we were paid. So we had a salary, and we had a stipend so that we were able to live there. And then after that, we all went to our respective regions. So like some guys went to Kentucky, or some guys stayed in Kentucky. Some guys went to Houston. Some guys went out east to Hartford. Some guys went to LA. And then I went to Chicago with another guy. And so from there, once I got to Chicago, I cut a few demo parts, just basic stuff with Mastercam, 2D machining. Took me a long time to do. I just cut aluminum. I galled the tool. I'm like, what's going to happen here? The material is wrapping around the tool. I'm watching it. I'm like, I don't know what's going to happen here. Nothing good. And that's how I learned. I just learned how to do some basic 2D machining and how to post the code. And at Mazak in Schaumburg here, they had a show every year. So for the show, I would always have to create a demo part or two, depending on how many machines I had. In the beginning, I only had one machine, but as I got more advanced or I got better, I got into doing two machines. And I stayed more on the milling aspect. The other guy really focused on turning, and I really focused on milling. It's just what we gravitated to. He gravitated more to the lathes, and I gravitated more to the mills. So after that, doing that for about 4 or 5 years, I was just really getting interested into 5-axis. And I didn't really know much about it. It just intrigued me, and I found it fascinating. So I left, and I went to a tooling manufacturer to try and be like a process engineer, but I wasn't really enjoying it. I saw that they had design engineers. I found that fascinating. So, I tried something, and, it doesn't always work out, tis life, and so then I went to Mastercam for about a year. I went to a reseller. And so I spend time now working with Mastercam, troubleshooting customers, working with the code, trying to understand the different machines, and some have to be wound and some can be unwound. Some can continuous wound, with these head machines. So I got some exposure to Mastercam and troubleshooting their customers. And then I was starting to get curious again, like I wasn't touching machines. I was running the software, but I was never putting that software into play too often. I did do something at a customer up in Wisconsin. I mean, that was cool, but yeah, I wasn't spending a lot of time like integrating that with the machine, because the end user is taking care of that. You're just assisting the end user.
Right.
So it was really funny how it all worked out. I was there about a year, and of course, like anybody, you want to like move up, you want to make more money, stuff like that. So I ended up leaving them after about a year, and I was looking around. So I was looking around at like Makino, OKK. I was looking around, and then the day that I left was the day that my current boss messaged me. I got an email. It was so strange.
Really?
And he was like, "Hey, I'm building a team here at Heidenhain in Schaumburg, and I understand that you are in the industry, you're looking around, and I've been told by some people to contact you and talk to you." And I was like, "Oh, wow." I'd gone to GF. So I had interviewed at GF. My boss came from GF. And what they wanted was a little more than what I could give them. So the guy who got the job had like 5 more years experience on me. So, they told me, and I was like, okay, they made me program a part in Mastercam, and they probably asked me about processing a part. And so I ended up talking with my boss, came into Heidenhain, and met with the head of marketing and with my boss. And my boss had just started, and I had 2 rounds of interviews. The second round, I met with the president, and I was hired. And they said that you're going to be part of this team that's going to build up the marketplace for Heidenhain controls and the visibility, and we've lacked that a lot for many years here. So the guys that I know here, like the RSM, one of the RSMs here, Dave Bogarowitz, who's works a lot with TNC end users and retrofits, has said, and he's told management here for many years that we've been needing application engineers both in-house and on site and to assist customers for like 10 years, and they didn't have it. So that's how I started here. I was under the tutelage of my boss, Gisbert Ledvan, and then also Dan Miller, who was the experienced machinist, and he had come from Hermela and GF. So I was, of course, I didn't know anything about 5-axis. I knew a little bit about running Mazatrol and running, Mazak machines, but nothing about these 5-axis high-end machines. That's what I was really interested in, was like, I really want to get into like high-end stuff. Like, I don't know, it fascinated me. I just wanted to kind of really sink my teeth into all the very detailed aspects of these 5-axis machines. And, I didn't know how I was going to do it. I just put my head down, and I had many rounds of Germans here. So I had 2 Marcuses, Martin, and so I had 3 German guys come throughout a few years to assist me, to basically train me. So I was trained by many Germans, and then I also went to Germany as well, and just spent a lot of time on the control. I didn't touch the machine really for the first 4 or 5 months. All it was running the simulators and really getting good at, or getting speed at, programming at the control and understanding just the basics of how this control works. So the German philosophy is, you want to build a very strong base, a very solid foundation, so that your peak can go higher.
Right.
And it's the same with like working out. It's like when you build that base, then you can go harder, you can go longer. So that's what I focused on for, I don't really do the base stuff as much anymore, but that's really what I focused on for probably the first 5 years. I would say it took me 3 to 4 years to really get comfortable, where like I can take questions on the fly. I don't have to prepare as much unless it's something advanced, and just coming into my own. And it's basically the school of hard knocks, or it's the school of experience. Get exposed, talk to people, work with the customers, and that combination, that collaboration is just so huge, because you end up learning from each other. And that is a beautiful thing, because everybody is getting something out of this. I'm assisting them. I know more than them. I'm the expert. but I will still rely on them for certain things. So it becomes a really good synergistic relationship. And that's basically how all of my trainings have been since I started. And I've done over now, I always like to say I've done over 100, but now it's like probably like over 130. So, I've done, between on-site and in person here, over like 130 some trainings. So, you really get some good experience and you come into your own. So that's kind of how I got started at Heidenhain. And it's been a wild ride, because Heidenhain's a control manufacturer, goes on an OEM.
Right.
So what happens when customers have questions about that OEM? What happens when something goes wrong with the OEM? What happens when they have a question and they think it's for me?
Well, and that's what I was going to ask you is when you've done these trainings, when does somebody go to Heidenhain versus their OEM? Like I've got a Hermla, they've got amazing service. Typically, I'm funneling all my questions through their support and applications. Why would somebody like me come to Heidenhain directly?
So Hermla gives fantastic training. They have a fantastic apps team. I would put their apps team up against anybody. So they're providing with a high level already. Mm-hmm. So it really just depends on the customer. When they sold your package to you, was training included?
We were lucky. We bought our machine very lightly used, but it still had both of the training seats on it, which is great.
So you're able to take advantage of that.
Yep.
So when they sell a machine, they're giving you the training, right? So not every OEM perhaps does that, and especially if you buy a used machine, that's not going to happen either.
I gotcha.
So people are buying a used Zimmerman, a used DMG, a used Micron, something like that. So they may go to the OEM, or they can come to us. So it just depends on the package that the customers buy when they buy the machine. Some don't know that we have training. We offer training classes here in Chicago, and we also offer on-site training. So that's been part of my job, is to get the market to not only understand the control, but help the market and show the market that we're here to help them. So I would say people typically come to us when it's a new machine and maybe training has not been sold with it. So
okay.
Training's not been sold with it, and they just want to hear it from Heidenhain. They just want to hear it from us directly. Some people are like that. They want to hear it from us directly.
Totally.
That's what we do. So we explain to customers how to operate the control, how to program the control, how to debug the front end, and then all the other little tips and tricks that we can give in a on-site training or a basic training. We call this basic training here, but it's not really basic training. So we call this, it's like a basic plus training, because there's so much to running a 5-axis machine, maybe not efficiently, but just safely.
Mm-hmm. For sure.
Just being able to run it safely. So that's when I would say they can come to us for training.
Okay. How did you feel going from a Japanese machine background to a German company? Because I know I've run mostly Japanese machines my entire career until we bought the Hermla, and I had to start learning Heidenhain and all that. And philosophically, they run so differently, and the way that the controls act and the actions that they allow you to do and don't allow you to do are so very different in some cases that it was almost like a mini culture shock starting to jump into Heidenhain. And did you feel that going from Mazak to Heidenhain eventually?
Yeah. Because I stepped up to a Hermla, as Hermla would say. So,
right.
So in our shop, we have a Hermla C12, and at the moment we have an Exeron MP9. So, Hermla is a very well-known brand, high-end brand. And there was some culture shock, because so you have the Heidenhain keys on the bottom, and then you have all these other keys on the right. And I was just starting to learn the Heidenhain keys. And sometimes you had to interface with these Hermla keys. Yeah. And it was like, what is going on here? Because Heidenhain's a control platform, and then the OEM is putting their stuff on top of that control platform. So you have to know the Heidenhain to an extent, and then you have to know some of these OEM buttons a lot if you're running this thing often.
Right.
Because when things happen, you have to be able to use those buttons. So I would say like with the German builders, I mean, and from what I see, I mean, they definitely, the way that they structure their operation manuals and the way they structure their soft keys and the logic there, I think it's awesome. And sometimes it can be the learning curve is you have to, there's quite a bit to learn, but how they manage things is really cool. But it's like, Germans, they may also make great cars, but like to work on a German car, it takes a lot of training.
Right.
It's like the same thing with learning like sometimes a German system. There's just a lot in there to wrap your head around. But once you start getting the basics, then it just really opens up a whole new world for you, and it makes your life easier. That's the idea behind our control and what we try to do. Like, it's to make the customer's life easier. But like I just pounded my head on the table for thousands of hours, like trying to learn that control, and that's how I was able to, like, it's like in life, like there's no shortcuts. You really, in order to get good at something, you have to spend thousands of hours on it, and you need to go back the next day and spend another 5, 8, 10 hours on it until like you're just tired from, like, your mind is just tired.
Right.
And my mind went through that for many years, but I would say the first year was the steepest. So the first year I was leaving work all the time, just tired. My head was tired, because after 6, like I would say I probably averaged 6 to 8 hours on the control every day. I probably averaged 6 hours a day for almost 6 months solid. So I think I equate that. I think it was somewhere around like 3,000 hours or something, or 3,000 or 4,000 hours in like 6 months, which is a lot.
Yeah.
And it's like what I had to do in order to get up to a level, because when I go out in the field, like, yeah, I can get the topics, but if I can't field the questions well, then okay, I can say, all right, I'll write it down and I'll see what I can find. And I had to do that, but I wanted to get to a level where like I didn't need to do that often. It was only on those complex issues, those complex questions. So yeah, I know, it just took a lot of pride in like, this control. I felt like, wow, like, I didn't know what I was going to do with my career. I have this ME background, and I didn't know if I would sit in the office. Would I work in aerospace? I was in aerospace for a little bit, but what would I do with this knowledge that I learned, and how could I apply it? And, I carved out a nice niche here in manufacturing for myself by learning this Heidenhain control, because this control is we are expanding our market share, and we get more and more people that contact us that just got a new Heidenhain, they got a new 640, or they just got a brand new TNC 7. So yeah, I just was like, wow, after a few years on this thing, I'm like, I think I might be able to make a very solid career out of learning this control to the best that my ability is.
Totally. Well, let's jump into some questions from the audience. From Patreon, Doug had a couple fantastic questions. He said, first up, what are the most underutilized aspects of 5-axis capability by most shops? So when you're going in, what do you see people, like, what blows people's mind? You're like, oh, you can do this, right?
Yeah. So a lot of people run with radius 0, and that's going to tie into other things I know. But, a lot of people don't run with the radius in the tool table. And so when you don't run with the radius in the tool table, you don't have collision protection on that tool. As soon as you put a radius on that tool has collision protection now built into it against the fixture, any part of the kinematic. So any part of that kinematic, the head, the table. Of course, you can't hit the head when the tool's in the spindle. But like if there's a fixture in there, anything else, a laser, you cannot touch that. So we provide a barrier around all the pieces of a kinematic, and that would protect the tool further.
And that's finally adjustable, right? Collision distance on 7?
So yes, it is adjustable now. It wasn't adjustable for a long time. right now, so I believe it's 2 millimeters. That's the closest you can get. And you probably know that. So if you get really close to your fixture, right, it shuts off, or you get the DCM alarm.
Well, with Hermla, they don't even have it active on our controls.
Okay.
For that reason, they said that they've had so many customers that need to get closer than that 2 millimeter that it was just a giant hindrance versus being a giant help. But
so
I've
they
got
have it turned,
friends.
but you can turn it on.
I think I have to buy the option. I don't think it's even active on my control.
Yeah, so it is an option. DCM, which is called Dynamic Collision Monitoring, is an option. It's option number 40. And so if you have DCM, then you're going to collision protect the tool.
Right.
So that's one of the most underutilized aspects of 5-axis machines, because you will have collision protection with that tool. And this, I would say, another thing that is underutilized too would be using kinematics opt regularly. So that's your 5-axis calibration. So it optimizes the center point of rotation for your kinematic, whether it's a head table, or table. Do you have any comment on that?
I do it fairly frequently.
Okay.
Probably, I try to do it once a week. Very often, it's like once every other week. But
that's good.
We had a listener and a friend, Ethan, come out and be kind of our quote unquote intern for a week.
Yeah,
and that was one of his
labs.
No, so Ethan works at Renscott right now.
Oh, Ethan. Okay. Yeah. I know him. Okay.
And so he came out, and that was one of his projects for the week, was creating a calibration pallet. So it holds the gauge ring, it holds a little piece of aluminum that we can cut for the Z probe calibration, and then it's got a thread for the kinematic sphere.
Okay.
And it's on a laying place.
What's his last name?
Patain.
Yeah. Okay. Yeah, I've spoken to him on the phone actually too, and seen him at IMTS.
Oh, awesome. Let's see. So his next question: since 5-axis machines get used a lot, if not mostly, for 3+2, is it wrong to view 5-axis as a relatively low barrier to entry way to automate by reducing setups? And then I thought his analogy, he said, asked another way, is it viable to say for automation, as a bar feeder is to turning, 5-axis is to milling?
Yeah, so is a low barrier to entry well, absolutely. Of course, it's a low barrier to entry because with 5-axis machines, you're reducing the number of setups, so you can attack the part from different angles using plane functions, and also you're increasing your accuracy, and you're also not having to unclamp and clamp it and spend more time to set the part up in another machine where you may have pitch, roll, and yaw going on. You may have some tilt going on that part now with just how the table sits or how it sits in the fixture. So yeah, absolutely, it's a low barrier to entry for automation because you're increasing the efficiency of your shop. And yeah, for automation, as a bar feeder is to turning, 5-axis is to milling, absolutely. So when it comes to so there's a lot of tiers. There's a lot of tiers to all of this. So, when you think of 5-axis, that's like your first step into automation. A 5-axis machine is a customer's first step into automation. And then, they might use it for 3+2. They might do 4+1, and eventually they might get into full 5 at some point. Most customers aren't doing a lot of full 5. Most of them are just doing a little bit here and there. It's only, maybe those aerospace jobs, impellers, turbines that are doing a lot of full 5. Turbos, where they're doing a lot of full 5. So like the first step or the first level is a 5-axis machine with those types of operations, 3+2, 4+1, 5-axis. When a customer masters that, then he can graduate into getting a pallet changer. So now he can use a pallet changer to run the machine. And while he's running the machine, he can be setting up the next job outside the machine. And he can monitor that. He might run a little bit over the weekend, but it's not an entire cell where you have all those complications of a cell. So a pallet changer would be like a second step. And then a third step would be like a fully autonomous cell with a articulating robot or, System 3R or an Aroa system where you have a robot in there to load and unload the parts and run overnight. And that would work in conjunction with whatever control was on there, the Heidenhain control.
Do you
So
see
I
more
would say,
customers going that way?
yeah, definitely yes, we do for sure. You definitely see it with the real high level machines, and you even see it with like the mid level, the mid level machines as well. So, yeah, so absolutely. You see it with all different levels of machines. I mean, that's really where we're headed, is just incorporating more automation into a process or into a part to be more efficient in the shop. One thing about these, and I think this ties in, one thing about I think it's one of your other questions, but one thing that ties into like understanding like a 5-axis machine for automation is using a clamp, like a pyramid style.
Yeah.
So
So our
if you're
next
using,
question from Ken, he was saying, as somebody he's looking into getting into 5-axis, how do you balance machine constraints and density, such as using a pyramid to run 3 setups at once? Some machines are just 5 or 10 degrees short in travel in terms of
Mhm,
getting over to each face of the pyramid, or you're looking at a very low angle pyramid. Are pyramids
mhm.
worth it, or do most go one at a time or have other options? So, like, what's your
So
preferred method of having higher density work holding on a 5-axis table?
so this was to be definitely tie into like mastering a 5X machine first before going into a pallet system, unless of course the parts were too big, where you have to shuttle them out because of the envelope size. But as far as like pyramids and are they worth it? Well, I would say that it would depend on the machine that you have, and hopefully that machine has some sort of simulator or digital twin that you can test out. So, and you can get the specs, of course, from the OEM that you're looking at. So with us, we offer these simulators that you can download online. They're free. So you cannot run a million lines of code through them, but they're they're free of charge to test, to learn for software engineers. So using something like that and testing out the capacity of the pyramid with your part on there before you are making that investment, I think is a really useful thing to step back. And if if you're worried about the 100 lines of code, most tool paths where you need to get in and out, like get 5 axis in and get out, that's under 100 lines. So, and typically 60 to 80 lines, or maybe even less, you can get in and out. It depends on how much comments are in there. But you would be able to use one of our simulators if like you had a Heidenhain control, and we offer a lot of kinematics available to those simulators. You just type kinematic in the mod page where there's the little code, and you can unlock, I think there's 15 simulators, 15 different types of kinematics built in there. You got your Grobe kinematic, you have your AC style kinematic, you have your BC style kinematic, you have some gantry style machines, AC, BC, and I think there's there's at least a horizontal kinematic in there. So that would be a great tool to use before you make an investment on a pyramid, is to make sure on these parts that, where you feel like, you don't have the travel because you're already sitting at some angle, to use some of these pyramids that you can now download. You can download STL files of these and step files. With Heidenhain controls, you can import that step file now. So you can import that step file into a simulator. And so from there, then you can use that to test your part. So that becomes part of your kinematic. It becomes your fixture. With software level 11, which has been out for about 5 years, you can import the STL model of any solid model that you have. And the numbers are, I believe it's 20,000 ASCII or 50,000 binary. So if you have less than 50,000 binary triangles, then you can import the STL. If you have less than 20,000 ASCII, then you can import the ASCII STL file. We offer a CAD optimizer button where you can shrink down that model quality size. However, on a simulator, that will not be available because people would not then have to buy that option.
Right.
Yeah, so you would have to use your CAM software to shrink that, or whatever CAD package you're using. There are a lot of free CAD packages out there that can shrink models, and then you could import that in and do your tests.
Do you find a lot of customers using pyramids, or do you see more one-offs, or do you see other things that you like better instead of a pyramid? Or
I see a lot of one-offs. I get exposed to everything, so I see a lot of big machines with molds, aerospace parts, and then I see some mid-sized machines like your AC, like your table machines, where still it's a mid-sized part, and then sometimes I'll see like really small stuff with Kern or with GF or something, and a lot of times I'll see automation with like Kern, or I'll see automation with GF. You'll see that.
But like if you were building up a work holding stack, would you go tombstone on a 5-axis pallet, or would you choose a pyramid, or would you just do it one at a time and then find a way to automate the loading? Like what is your preferred method?
I think it depends on like the complexity, like where you need to tack the part at. So like on a horizontal, if it's a small horizontal pallet, you may have some issues with the Z travel. You may have some issues with like getting the tools around in there. It might be kind of high for that machine. Whereas the pyramid's going to sit a little bit low, and you can utilize the A and the C table to get access to the pyramid or the tombstone. I think if you want to do more than 3 parts at a time, then you're definitely looking at tombstone if you're going to do it all in the envelope at the same time, in one pallet. So I think it just depends on the parts and the complexity, what you're doing with them. I really don't have a preferred method, because you can get at it from CAM through any way, and as long as the machine allows it. And then sometimes that's where we come in. If, for example, they don't know how to set up the job, they don't know how to probe the plane, or they don't know how to set the pyramid up, or they don't know how to relocate the pyramid in the machine. Typically the pyramids are typically on a table machine. Everything's going to come in on center. But if you ever need to move a fixture or whatnot, then there's a little more involved. You'd have to get into the config files of that pyramid. I would have to attach it to a CFG file, which that's a configuration geometry file, in order to shift it. Or we could use the TNC7 and we could shift it automatically in the digital world and then probe it in the real world. So we could do it very simply if we had a 7. So yeah, I think it just depends on the size of the part, and and what and how many parts they're looking to put in there.
Okay, awesome. From Instagram, Dakota from Zone 5 didn't have a question, but just wanted to let you know that you're the man. Yeah. Chathan asked, what do you think
Thank you, Dakota.
Chathan asked, what do you think about spline interpolation? So how does Heidenhain handle that?
So spline interpolation, I think that's really cool. I've been to some really high-end shops, and some of them do use splines. And splines, if people don't know, splines just have a way of making the surface shinier with the waveform that's created, and it just is very appeasing to your eye. So that's why splines are so cool and unique. I've actually been watching some videos on splines on YouTube. There's so many different types of splines out there. I find them very fascinating. Man, they're involved in so many aspects of design and engineering. Yeah, from cams to bridges, like make things move. They make animations. So splines are really, really cool. And Heidenhain has on the 530, we had something called like NURBS interpolation. So we had NURBS on there. 640, we don't have NURBS, but of course, if you make splines, like it's going to read them as lines, and they're gonna process through on the 640. So we'll handle that no problem on the control. But I'm very interested in them, and I'm trying to figure out like how I can utilize that. We have formulas that we can create. We can create custom formulas, and we can also tabulate data like in tables. So I've just been thinking like, man, it'd be cool if I could get some sort of cool spline, and then I can tabulate that in a table, and then I can use that to create the program. So I can use like a macro program to create the spline. I can then tabulate all those spline points, and then I can use the control to drive those points. They're pretty unique, and I think it would be cool to. I know customers are using splines to drive their machines, and I think it would be really cool to pair with a software company to do something cool with splines, where we feed data back from maybe a formula to create something.
That would
And
be
I don't know if it
awesome.
would be 3-axis or 5-axis, maybe just 2-axis to start. But, it sounds like it would be something neat. Yeah. If you have never looked into splines, it's really cool. You should watch some videos on spline formulas and how complex they are. Also do with math and derivatives. They're pretty cool.
Awesome. Next up, and this was a question that had come up before, but I can't find it on Instagram. But Possum Solutions asked, older Heidenhain controls on used machines, parts availability, ease of use in the modern era, etc. And somebody else had asked, how old of a control would you go back to and still feel like it's a modern control? Like if I was buying a used machine, would you cut it off at 530? All that stuff. Let us know about old Heidenhain.
Okay. Another loaded question. So, I prefer, obviously, I know Heidenhain's really well, so it really doesn't matter. That the cool thing about Heidenhain is it doesn't matter what Heidenhain control you get on, they're all going to look the same, and they're all going to, as far as all the Heidenhain keys, it's all going to behave very similarly. So that's the cool thing. Once you learn the 640 or the 530 and you go up or down, it's not a big jump anymore. The buttons are all in the same place. The colors of the buttons are the same, like the orange buttons for the axis keys. So the ease of use of just going from one Heidenhain to the other is seamless. It's very easy. Like, what would I prefer?
Let's say I come to you and I said, hey, I want to buy a used Heidenhain machine and I want to run modern code with, adaptive clearing and high-end surfacing. Can I do that on a 530? Can I do that on an older control?
Yeah.
Where does that line cut off?
I would say 530.
Okay.
I would say 530. 530 is where I would start. Some people have 426s, which are, older than the 530. Some people have 426s, 430s. And, you go in the shop and I train them on 640, but like these guys have experience on these older controls and they're like, yeah, we prefer this control out of all our controls, and, it's because they may not understand everything too. So it's not just the control that the customer has bought. It's the motion package.
Mm-hmm.
They've bought the Heidenhain scales. They've bought the Heidenhain encoders. That's a motion system that the Heidenhain is using as a feedback technology. We call that a closed loop system. Not everybody knows that. So as soon as you add another layer of feedback into a motion system, the level of accuracy is a big jump. It's a standard deviation jump. And the level of accuracy you're going to get. And because you have scales and encoders on there, you're also going to get a better surface finish too. So I would say the 530. And as far as parts out there, we have distributors that are still carrying parts. For 530s, hard drives, for the older controls, the 400s. Of course, that stuff is harder to find. But that stuff is still available through some distributors that we have in our network.
But not direct anymore? Heidenhain themselves won't sell 530 parts?
Not entirely sure. I think we may, but it would be expensive.
Okay. Riley Gilman asked a near and dear question to my heart because I also struggle with this. Tool radius, tool large errors. Why does it happen more times than I want? So you mentioned people running 0 in the radius column. I think that's probably because of this error. I know I post out a lot of toolpaths without cutter comp on because I encountered it so much. Why do I get it? How do we solve it? You gave me kind of a workaround over email or LinkedIn, but
did you try it?
I did. It works great. I'm not using it because it's just more work. Like I would then have to laser and then change things.
We should explain what that workaround is first.
Yes. So explain your workaround. Oh, I guess for people.
And by the way, in all fairness, it's not my workaround. I didn't come up with it. Kyle Brunner shared it with me earlier. I think it was at IMTS last year. Shout out to Kyle. So what he's told me is that if you're getting this alarm, you post out radius in your CAM program. So you run with radius in your CAM program, and then of course you're running with radius 0 on the Heidenhain, or no, then you're putting the actual radius in the R field on the Heidenhain control. And then with the DR, which is the delta, you have wear columns. You have DR, DL, and DR2. On the DR, you comp it back.
Mm-hmm.
So you're essentially just you're using the radius, but you're turning it off. You're copying it back. So just how your cam is. Otherwise you'd have a mismatch by half of your radius.
Yeah, you end up posting out wear comp instead of in control comp. And then, so for example, a 1/4 inch end mill, you'd laser it and it'd be, 0.615. And then in the DR column, you'd have negative 0.625. And so it knows how much to comp that wear tool path. It would be the delta between those two. And so you still get cutter comp, but you're cheating it and you're at very near 0 R in the control. And so you don't get that radius too large error nearly as often.
Yeah. So on a 1/4 inch tool, then your radius would be 125, right? So it'd be 1/8.
I'm sorry. I said, I meant 1/8 inch and then
so
did the math for that.
So if you were 1/8 inch, then so it'd be 62. And then you would comp it back, or you would essentially set it up like your cam. So you would take the opposite of it for the DR field. Kyle has said that has worked great. And you said you posted out where, correct?
Yeah. Yeah, because then you're only looking for the delta to move the tool path off of the program line. You don't want to move it. If you posted in computer, it would think that the tool is the diameter of the delta there. And so it would think that it was like a 2 thou end mill and not a...
Because I did try it like end of last year, and I did run into some troubles with it myself. I was working through that myself. That's why I was confirming with you.
Okay, yeah. So if you send it out as where, it worked for me. It's just... I think I just need to sit with it more and kind of figure out, because then you get into the problem of like, okay, if I want to make my hole bigger, then I need to add more negative to the DR that's already the radius. And so the numbers get a little murky of like, where do I start adjusting things to make sure that things work?
You would adjust it on the DR field.
Right. But you'd have to go negative to make it bigger.
But you'd have to go negative to make it bigger.
Yeah.
Which typically on the Heidenhain, you go positive to make it bigger. Right. Yeah. So it's opposite of how you think.
Yeah. It's just when there's numbers in both columns equal to each other, very equal, it provided enough of a pause that I just didn't standardize on it yet.
So have you ever, I'm all about stuff on the fly and thinking in here. And when you're encountering that, or you feel it's cumbersome, you could write a very basic macro, and that macro could be called into the main program, and that macro could take the DR field and any comps that you have to make, you could create it. You could do an absolute value. So like if you put the wrong number in, it would still give you the positive number. So you could say to send the data into the DR field, it's going to be this number, but I want to make the absolute value of this number so that you always put the right numbers in there. And of course, you're going to have to add 2 numbers. So you're going to have to add what's in there to this absolute value number.
Mm-hmm.
So it's like, and we use Qs for variables. And so it'd be just a simple formula of Q is equal to the system ID of the DR, which is going to be ID 50 number 4, something like that. ID 50 number 4 index. And then of course it's index. So what tool number? If it's current tool, then you can just set index to be grabbed from the current tool, which I believe is number 20 in NR1, which will give you the index number. So you could very easily macro, like looking at the current tool.
Mm-hmm.
And it would be the DR plus this field that you want to add. And that would be an absolute value field, so that it always adds a positive number in there to go more.
Okay.
To go deeper. And that macro could be on a finish operation or something.
Right. So two questions from that. One, I want to jump back to his original question was, why does this happen?
Okay,
this error.
Mm-hmm.
And then also talking about macro programming, I'd love if you could share what is the best resource for Heidenhain macro programming that you found.
Okay. Yeah, so this tool radius is too large. So why does that happen? So it's in our basic training book, and the way I understand it, because I've been a Heidenhain a long time, but like I never went through like traditional G code language. I basically learned all this radius comp stuff, and I learned it through doing and through listening from the Germans and trying and trials. So this alarm we get because the tool is too large for the arc that it's trying to go into. Mm-hmm. So the control is looking at, so whether they're going to be line moves or circle moves, the control has a look ahead. The control has a look ahead. Let me plug my battery in here. The control has a look ahead. It's a 500 block look ahead. It's like 0.5 milliseconds. So if it looks ahead and it sees an arc or it sees a circle, so if it sees linear moves in an arc and it sees that the tool radius cannot fit in that arc, so like you're going to bark in those corners, then you're going to get that alarm. So it's when the radius is too big to get in. That's why we typically see that. Now there are Heidenhain in some ways to circumvent that. There's an M code we can use. You could look it up. It's M120. I haven't had a lot of success with it. You would not want to do it with any thread milling. I know that for sure, but I've tried it. I just haven't been really successful with it when it comes to using that M120, and it has a LA, which is a look ahead on there. I mean, the look ahead goes anywhere from 0 blocks to like 99 blocks. So there is a way where you can circumvent this to get it to work, but I haven't been like really successful with it myself personally.
Okay.
So, typically what we need here is we need a smaller tool. That's typically the issue. And I think it's the control trying to protect you from yourself. I think that's what it is.
Right. Well, and that's when going back to my question about culture shock. That is one thing I found very interesting between Japanese and German machine tools is that, the Japanese, like my brothers, if I try to put a size on tool into its radius, it will just do its best and let me do it. And then when I started talking to support about like, why do I get this tool radius too large on my Hermla? They're like, well, you would never put a tool into the same size radius. I'm like, yeah, but I am. So how do I get past this? Like, I understand I shouldn't, but like, if I want to, what can I do? They're like, well, but you just wouldn't do that. And I'm like, no, I am.
But you wouldn't. Yeah. See, yep, right. Yeah, that's totally the mentality.
Yeah.
And I've come across this too, and as you think about it, it's like, if I use a smaller tool, it works. It's trying to protect us from ourselves. So that was one way that you could circumvent this, like what we talked about with the wear. There's another way that's coming out with TNC 7 called Tool Shape. It's out with software level 18, and Tool Shape allows you to import the STL of the tool now.
Okay.
Not just of the holder, but of the tool.
Okay.
So if the tool is a barrel, a lens, that's the idea there. So for the more complicated tools, but of course for stuff like this, for more basic drills, in this case, end mills, we can load in the STL of that tool shape. And now that radius field, I don't think it's going to matter so much anymore.
Oh, really?
Because it's always going to be looking at the data from the STL. So STLs are, I work more with the control than I do work with cam. But like when you work with these STL files and you probe them and stuff, you see that there's data in them, and that's just something I just figured out, in the last 2 years, maybe. Because I don't get exposed to it all the time. Like I never probed an STL file. I never like inspected an STL file. But there's data in there. So if there's data in an STL file, one would reason to believe that is also going to help us with this radius column field issue that we have now in time with this tool radius too large. So yeah, that comes with software level 18, and it's a new function. I think it's standard, so it's not an option or anything. It just comes with software level 18, and this is available only with the TNC 7 control. So unfortunately, if you have 640, even if you have 18, I don't think you have this available to you, because we do have 18 here, and I don't see anything about tool shape.
Okay.
So that will be a way around this tool radius too large error as well, I think, going in the future. So that's something that I will be playing with in the future here when I have a chance to work on TNC 7 more regularly. Like right now, we don't have one in our shop. We have pedestals and simulators, and right now we're in the middle of retrofitting a TNC 7 on a 3-axis machine. So I don't get a chance to play with it in all these scenarios, but yeah, going forward, I'm interested in messing around with that to see if this tool shape will help with this alarm and how will that work with the radius in there. Because I think the machine's going to be using that R field.
Right.
So, why do you need another R field in there? Maybe I could see the where's working, of course,
Mhm.
but then why would you need another R field? It's going to take the data from the STL file and use it.
Right.
So that's something I'm looking forward to here in the
Awesome.
future.
Very cool. A last question from Wisconsin Cam. What can we expect to see from Heidenhain in future updates? What are their priorities for developing right now?
So I would say with this future updates, look at the TNC7 and just look at like where it's going. The TNC7 now, software 19 is about to come out. Software 18 is out. This TNC7 is pretty wild what it can do here. So it's got this new model aided setup. If you haven't seen it, you could go on our website and look. That allows us to probe a fixture in the digital world. So you import the fixture in the digital world, and then you have the real fixture in the machine, and you put them about in the same spot where they are in the digital world and the real world. So you put them in about the same spot, and you're going to probe the real world, and at the same time, it's going to probe the digital world. So we call this model aided setup. We're going to use the fixture as the model to probe that fixture, and then that will set up that new fixture's collision boundaries wherever it is in the machine. And this can be a three axis setup or 3 plus C axis, and then it could be a 6D setup if you had like pitch, roll, and yaw.
Mm-hmm.
So if you have pitch, roll, yaw in there, and then you have your XYZ. So that's something really cool that we have with the TNC7. I think also like production autonomy. So not just like importing fixtures like what we can do with the TNC7, but also like production autonomy, which we have something called process monitoring, where we set so the Heidenhain control has a lot of signals that we're already monitoring in the background. And for our process monitoring, we are now using those signals to set benchmarks for the cutting process.
Oh, cool.
So we use these signals for voltage, current. You can set standard deviations on these. You can do all sorts of wild things with how you can control these signals or have your control limits on these signals. So the idea behind a process monitoring is you have a production of parts. You have maybe 5-10 parts, maybe a small lot size, maybe a higher lot size, but it's like production autonomy. So you're going to run your first part. Once you know your first part is good, we're going to record those signals on that run or on the next run. And then what we're going to do is we're going to take benchmarks of those signals and we're going to set control limits. However we want. We could control all sorts of things regarding that. Like I said, voltage, current, spindle load, all these things we can look at. Feed rate, and we'd be able to look at the feed rate. And so we take these signals, we set these limits on them, and then we create reactions for those. So as long as you fall within a window, we're okay.
Mm-hmm.
If you get kind of close, we can provide a warning. And if you go outside the tolerance, we can provide another warning, a red warning maybe, and we can then create a reaction on that. So we can say, hey, we want you to stop this immediately. Hey, we want you to finish this job and stop the job, or just notify us it's okay.
Right.
So we have all these reactions on that as well. And the cool thing is once you set up some reactions that you kind of like for your machine, you can save those reactions and then you could reload them in for the next job. So you don't have to keep creating reactions each time. Once you find maybe you want to do like feed rate and maybe spindle load. And again, I've spent hours on it, and even me, like I don't understand it all completely because I don't have like a 7 to work with on a real machine. But it's pretty deep, like how far you can take this. And so I think that's where we're going to be going. Like the control's designed for you to get closer to it. Like our panel is more ergonomic. We can now draw on the control, or we could import a contour into the control, and then we could change like a radius in there. We can then chain it back. We can generate Klartex code, and then we can shoot that back into the program. So we can do all this stuff where like in a job shop environment, if you wanted to make a change, and then we can do this automation stuff with this process monitoring. And the biggest thing when it comes to these machines is making sure we keep them running and running safely. That's where that 6D setup, or that's where that model aided setup comes in to really help the customer protect their spindle from that fixture that you put in there.
Right.
And on top of that, I think I mentioned about like the DCM, and there's a 2 millimeter barrier with software level 18. And if you have a TNC7, you can reduce that barrier down to a micron or 100 microns. So you can now take that 2 millimeter barrier around all of your fixturing and drop it to like 50 microns or 5 microns or 0. If you literally want to get like kiss the top of the fixture, which I don't know, you ever want to do that. But if you ever needed to, it's going to be a little tough on your tool probably.
Yeah. It's always been surprising to me how much data the control collects. Like somebody brought up the oscilloscope that you can bring up in Heidenhain.
Yes.
And that's amazing. I've never seen that on another control.
And I forgot to mention that. I was thinking, and I wanted to mention that on the first question. What are people not utilizing in 5-axis machines? What if they have vibration and stuff? Yeah, of course, you can listen. You can use the RPM. You can use the spindle RPM knob to listen and find it. But if you really want to tune that, like if you want to actually see that wave, you can use the oscilloscope in the control to see that. You would look at the spindle, you'd look at the channel spindle, and you would look at the S-diff. I picked this up from Chris Morton at Kern. Shout out to Chris. Chris is a smart guy, and he showed this to me for when he's doing like really high RPM spindle machining and he's worried about vibration. He's going to use the S-diff in the oscilloscope, and we're going to look at that channel, and then we can use the RPM to tune that. So we can check and we can watch the oscillate, the vibration, and we can bring down that natural frequency. That's something that's always stood out with me that he showed me, and I've spent some time in the oscilloscope myself, but mostly oscilloscope is for service engineers to diagnose a problem, voltage drop, current issues. You can diagnose things on the machine there. But, that's a great application where like you could use it in a vibration setting to reduce the harmonics.
Yeah, and it's just built in. Like that was what was wild to me, was that it's just like, oh yeah, you just, type this code in mod and boom, there you go. Like,
yeah, it's been in the 640s, it's been on the 530s. I don't know how far back it goes, but and yeah, the oscilloscope is just a small piece of if you had this Heidenhain software TNC scope, which you get if you are a Heidenhain service engineer, or if you go through the Heidenhain service training, you may get it, or if you become a retrofitter, or you have to work with the control backend, and you take PLC 1, then you would have access to this, what we call TNC scope. And TNC scope is even crazier. You can view a lot more different channels, and you can change the gains on the control, and you can send things back into the control when you're connected. But the oscilloscope is great just for like service engineers or people that are like apps guys that are wanting to get something out of the control by just going in there and seeing the frequency of the spindle.
Yeah, it's super cool. Well, that brings us on to shop news and new things. So what is new in your world? What are you playing around with lately?
Man, so lately I've worked with L stylus probing. So we now offer an L stylus technology to be able to probe undercuts. So Heidenhain offers this. You can buy this little adapter that goes into the Heidenhain probe, and we can use this for probing in aerospace parts, which is something we needed for a long time. And you can use this for probing anything else that you need where you may need to get underneath it. So this came out with software level 17, and this works in manual mode. So if you want to use it in manual mode, you can. And you can use it with any of the new 1400 cycles. So any of the 1400 cycles, which are our more advanced probing cycles, which are, if anybody's not familiar, they are a combination of rotation, position, and measure. They are a all-in-one cycle. So you don't get into them right away unless you really want to spend a lot of time in probing, because they're more advanced. So not to shy you away, but like I would say I always like learn the basics first. That's so big when it comes to these high-powered controls. That's kind of like the best advice I could give to anybody who's on a high-powered control, is like just start with the basics, like learn the basics. There's something to be said about building that foundation. So yeah, these 1400 cycles will probe for position. They can also figure out a rotation. That rotation can go into your preset table, whether it's a C-axis offset or a or a spatial C for a skew angle. And they can also measure and interrogate, like all in one. Like they're pretty wild. You asked something about Q parameters, right? Was that something you
Oh
wanted?
yeah, I forgot to circle back to that. So, what would you say is the best resource to learn about macro programming in Heidenhain?
So we have a unique website that comes off of our main website. So if you were to go to heidenhain.com or heidenhain.us and you were to go all the way down to the bottom of the page, there should be a link that says Klartext Portal. Klartext is our language. It's called free text, and that's the Heidenhain language. And so you can go to that link, or you could just type in heidenhain-portal.com. And that link has a lot of tips and tricks. There's a lot of programs that you can download there for free. There's a lot of problems and solutions. There's a lot of there's a lot of macros already built in there for like probing a high spot, probing a low spot, finding the midpoint. There's like multiple types of cool programs you can use in there that are already built. And then there's a section on webinars. And in that webinar section, they're all free webinars that you have access to if you're on this page regarding our control in the different cycles behind it. So one of them, I think the last one, is Q parameters.
Okay.
And I didn't do it. One of the guys in Germany wrote it or gave it a few years ago, and it's pretty good. I've listened to most of it. It's, I think, like about an hour, and it's going to give you like kind of what I would do, but in 1 hour. If you didn't have me, you'd be able to pick up some basics on Q parameters, and there might be some examples that they go through in there too. So it's just going to go through like the introduction of Qs, the different types of Qs, the different formulas you have, and then like how to use those formulas and do some basics with those. So yeah, that's how you could get started with macro programming. Of course, you can download the conversational manual. You could go to chapter like 9 or 12, something like that would be your Q parameter programming. And there will be some great resource too, but that's going to read more like a manual. Still great though. I mean, I have found the manuals to be really good. I'm really was impressed with the Heidenhain manuals when I came here. Yeah, at times, sometimes it's a little germlish, at times, and sometimes
right.
I have a hard time making heads or tails of it sometimes, but for the most part, like it's really great. And I've taught myself quite a few things in there. And if people don't know, that manual is basically built into your control. You probably know that, right,
yeah.
Dylan?
It's awesome.
Yeah. So if you hit cycle def and you say go to it, it will pull up all the cycles. Or if you just open up a block and you press the help button, if you're in a cycle, it'll bring up that cycle with all your Q parameters, and it'll give you your units, which are awesome because sometimes you don't know what the units are on this thing. Like, is this degrees? Is this feed rate? What is this? What's the limits? And then if you're on a block, it might take you to the conversational side where it talks about blocks. And then at the top, you have a little search function. So you could type in something there, or you could go to your index. So yeah, when I'm at customers, sometimes I do go in there because I sometimes I got to pick stuff up too. Like at some point, your knowledge gets a little fuzzy when you don't do it every day. Certain things.
Well, there's a lot of things in the Heidenhain control that I've noticed have, hour-long videos online. And like when you got so many of those, like, plain spatial is another one where like you can spend hours and hours and hours learning all the intricacies of it. And so, I don't blame you for opening the manual from time to time.
Yeah, tis I have. I spent a lot of time learning plane spatial, and we have a planes class, and I just put it into the control and, feed it to it, and like it's a simulator, and feed it to it and figure it out. Plane spatial is all using the right-hand rule. That's the biggest thing I could say about it, to not be too long, is plane spatial uses all the right-hand rule. It doesn't matter what the kinematic is. So it's a head table, head, table. It's always using the right-hand rule. And it's a concept in space. So if they were to look up the right-hand rule and look up spatial angles, you would probably find that synonymous. It's widely used in 5-axis machines, and I think it's an advanced concept, but it works really well when you have multi-axes.
Oh, for sure, yeah. But it can get very complicated, especially if you're not like super advanced on the math behind it. Like when you have an AC machine, but then you have plane spatial with like an SPB.
A B.
Yeah. and having like an interpolated B axis is it's a complicated thing.
It is. It is. And so and what I have found is that the CAM softwares, they typically won't do that. So they try not to mess with you. Either they don't know or they just try not to mess with you.
Right.
So, so when they create the machine model, it'll be like for an AC, and then they'll use the spatials A and C. But you could use a B. So instead of using the A and C, you could just use the spatial B, because it's just a concept in space. Like, I just want to go this way instead of using the two together. I'll just use the one angle, and then the control's smart enough to know when it sees one angle, but it has the other two physical angles. Okay, I'm going to use those combination to get into that position.
Right.
The only thing, so that's one reason that it's just a hunch I have. And the second reason would be if you're using a spatial angle you don't have, which you can. If you're using one you don't have, it can complicate your setup a little bit, right? Because if you stop the machine and you're in a plane, it has rotated your coordinate system.
Right.
Now, sometimes your coordinates do rotate, they have to sometimes, but if you rotate around an axis you do not have, it will rotate the coordinate system. So that means your X will now be your Y in some fashion.
Right.
Yeah. So just for people to understand that, I think that's a really big thing to know about, like maybe why CAM softwares don't do it, and maybe a safety thing that people should know about when you're in like 3+2.
Yeah. I've got all of that written in a section in my MDI of like a safe retract and cancel of all of that stuff, just so that I don't have to like worry about it if I stop a program in the middle of a 5-axis move or a plane spatial or something.
It's always safe to have. Always good to have like an MDI. If people don't know, our MDI has like all the data. It stores all the data for you. And what a lot of customers will do is, put tool calls in there, plane spatials, turn on and off 5-axis, and maybe at the top they have their safety moves. So they have their plane canceled, and they have maybe their M140 if it's a table.
Yep.
And then they have their plane reset turn, or they have their LAC, LAC Fmax. A lot of ways to get in and out, and that's up to the CAM what they want to do. And so, yeah, that's useful. Kern has a nice M code, I think.
Oh, really?
Kern uses like M23, and even Grobe uses an M code to retract the spindle all the way. And even Kern uses an M code too, to retract the head and then rotate everything back.
Oh, that's cool. That's really cool.
And if anybody were to take you might have to take our PLC class, or you'd have to get involved with Heidenhain, but you can create custom M codes in the control. So you'd have to get some training from Heidenhain service. I shouldn't really give that stuff out. I know about it, but you could create a custom M code to do that stuff, which is like what Kern has done there and Grobe has done. And it definitely helps, So you always want that stuff up there, especially for people that aren't like really up on like what happens when it's in a plane or when it's in 5-axis. When it's in 5-axis, it's a little gnarly sometimes, right? It's a little bit of a mind trip.
Yeah.
When it's in 5-axis.
Well, and for me on the Hermla, like I'm usually down with the spindle towards me, and so like if anything happens and it needs to go tool change or anything, like it's going to go through the trunnion most of the time. So like I need a way to get up and out of the way and clear the spindle and all that stuff.
That's right, because you don't have the DCM. You need to get DCM, I think. No?
We'll see. Maybe my next one will just have 7, and then I can not worry about the 2mm.
Yes. Mm-hmm.
All right. So we are down to the last questions I ask every guest. These are actually new from Patreon. Y'all have submitted and voted. First up, what is one CAM, metrology, or business tip or trick that helped you this week? And I'll go ahead and add control in there for you. But what is a tip or trick that helped you out this week?
I don't know. I thought about this, and if you're talking about this week, because I don't use CAM a ton, so I mean, of course, I'm involved with metrology, but as far as things that help me on the control, like what helped me this week, I mean, it's something that I know already, but it helped me. So I was at a customer, and they couldn't use the magazine. Oh, they didn't have air, but yet we still wanted to load the probe in the spindle. So you can do that. You can do that through the pocket table. So with pocket table, with line 0 in the pocket table, You can zero out that line, which is what tool number would be currently in the spindle. So pocket zero is what's in the spindle. So you can zero it out there. And then what typically happens is then you go into MDI and then you do so you'd be zero, or you would clear it out. You wouldn't put zero, you would do clear. And then you would go to your MDI and you would say tool call zero. And that would take any data that was assigned to that tool. It would remove all that data out of the spindle probe, or out of the machine probe, or the machine spindle.
Mm-hmm.
So now at that point, if you needed to load a different tool in there for whatever reason, you could. Like, you need to load a probe in there to do something. Then you could go back to your pocket table, load in what the tool's probe number is, then go back into your MDI. And if it's, let's say, tool 20, then you would call tool 20, cycle start, and it would load all the data in. And now you could either put the tool in now, or you could have done it at some other point in that process. So sometimes that's useful to load tools in and out of the spindle. And yeah, I would say like that's something that helped me. I did a macro probe class virtual a couple weeks ago, and I used a system ID. They were running all in inch, and with Heidenhain, we have a system ID that will interpret everything as inch. So if people are ever trying to do stuff with Q variables in an inch program, it would still interpret it as metric on the 640. Well, we now have a system. Yeah. So we now have a system ID. We've had that for many years, probably like 5 years, 4 or 5 years as well. Where, like, so if you're doing stuff in inch and you want to see all the stuff in inch, then you got to use this. So like if you want to output the data and you want to output it as inch data, like in a table file or in this case, we were outputting it to an ASCII file. So if you're outputting the data to an ASCII file and then you were converting it to a text file and you wanted to see it all as inch, I use that system ID that we have. That's kind of like, not everybody knows that unless they get involved and they contact us because they're like, hey, I'm in an inch program, but my Q parameters are metric. Okay, yeah, you need this system ID in order to do that.
Okay.
So that's something that helped me, because I was like, are you guys an inch or metric? And they're like, inch. I'm like, okay, then we got to put this code in there.
Cool.
So yeah, I would say those couple things helped me the last few weeks.
Those are great. What challenge are you facing and where are you looking for help?
What challenges am I facing? Probably just time to be able to do cutting. I'm just involved so I'm in the marketing department for Heidenhain because that's how it's set up in Germany. So,
interesting.
I'm in applications. Applications is part of marketing because we are the support for the control.
Right.
So we are the support. We sell the control package to OEMs in the US, and then of course stuff comes over from Germany and is already cooked, let's say, and then it's installed. And then we might get called for that. So yeah, I just do a lot from a marketing standpoint, shows and trainings and customer questions and customer problems and quotes for trainings that, yeah, I would say I don't cut that much. And so I've been working with a couple cam companies and they're helping me to get some demos on the machine because I just don't have time to get in and do that until my position morphs more.
Right.
So I'm I'm in a hybrid role really right now. It's a hybrid between customer facing, sales, customer facing stuff, and solution orientated with problems. So, I am kind of wearing both those hats where, I'm a specialist on TNC controls, but I'm also this trainer and application guy on the control as well. So yeah, it's a hybrid role, and yeah, just finding time to get in the machine and cut something is sometimes challenging. So, but when I make them part of things that I want to accomplish for the year, then it makes it easier because I'm focused on that.
Awesome.
So that's what we're trying to do we want to do a few more workshops this year with our OEMs in collaboration with some CAM softwares. And what I want to really try to do this year is cut with PCD tooling. So I want to shoot some of that and see how that comes out. I'm interested to kind of dive into that and see what kind of services we can create with these PCD tools and cutting, stainless and hard exotic alloys. So yeah, that's an avenue I haven't really spent a lot of time in. Of course, I do demos and I do cut and stuff, but when I do trainings, we'll cut something. But yeah, like I just want to like get involved even more, because like you get into problems that way, and that's how you can troubleshoot, problem solve, and maybe use something on the control that you didn't think of.
Totally.
Like for example, like our spindle pulse or our feed pulse. Yeah, that could tie right in like that last one. This is perfect. So like so we have a spindle pulse and we have a feed pulse. If people don't know, it's built into 640 controls. It may even be built into 530. I'm not entirely sure, but we can pulse the spindle. We can also pulse the feed rate. You can pulse it for a duration, so like a split second, and then you could have it go for another 10 or 15 seconds and then do it again. So for example, chip break.
Mm-hmm.
Somebody asked me like, okay, how does Heidenhain solve like on a turning machine? If you're doing a mill turn, because we go on BTL style machines, how can we solve chip evacuation issues, chip stringing? And I was like, man, I don't really know if we have something. And I was in a meeting yesterday. I had a customer doing this just a couple of days ago. And the more I thought about it, like over like an hour, I was like, well, we do have a feed pulse, and I think that would work. So we could pulse the RPM or the feed per rev on a turning machine for, let's say, like 50 milliseconds or something, maybe less. And then, so we don't have to talk to a tooling manufacturer. Okay, what would you recommend for this? And then then go on for another 5 seconds or 10 seconds, and then have it happen again. So we have this feed pulse built in as a 640. It's not even an option. It's on your control.
A cycle or is it an M code?
Okay. No, it's a cycle. If you go to special functions, it's under program functions.
Okay. That's super cool.
The spindle pulse you could use for maybe vibration. I've tried using that before, but the feed pulse, I never could think of an application for it until this guy asked me a few days ago about chip evacuation or chip stringing on turning machines. And I'm like, yeah, that's actually, I think that would work. So it's funny how your brain works. You don't think about, your brain subconsciously thinks, and then just something comes to you over time. It's funny how that works.
Totally. All right. Second to last question, work-life balance. What does it mean to you and how do you manage it?
So yeah, my work-life balance now, it has changed over the last, I'm about to have a child, so it's going to change a lot more.
Congrats.
But thank you. So I would say my first like 5-10 years in the industry, I was working a lot. I was doing more 10, 12-hour days, especially even learning the control when I started 8 years ago, spending more time here. And so nowadays I try to do my 8 to 10 hours and then I try to get out. And it's all about prioritizing. It's prioritizing and planning. So like, my work-life balance it has to be there so that I can assist my family and help at home and stuff. So and in order to get things done, I just have to prioritize more. So I've learned now just this year, like, okay, I'm going to set priorities. Like I'm going to set like things that are urgent and then things that I'm working on.
Mm-hmm.
And I set like kind of colors so that I know. And I plan a little bit more. So now I'm using Planner. I'm using like Teams Planner to help a little bit too. I think that's pretty neat how you can work with people on that. So I think planning is really the big thing so that you have some sort of a work-life balance. Of course, if you have your own shop or whatnot, it's a little bit harder, like my wife is like a pharmacist in charge. And so she's just got more on her plate than me. Yeah, sometimes she's going to spend a little more time. Like there's a lot on the line all the time, like with her job. So it kind of depends on the industry you're in. But for me, yeah, I've tried to scale it back to, more like 8 to 10 hour days when I'm at work. And then when you're on site or like when you're at shows, like, all bets are off,
Right.
So yeah, when you're on site, whatever, sometimes it's 10, 12 hours because you're traveling and whatnot. And, sometimes something comes up or, you just have to adjust.
Mm-hmm.
So yeah, but you can control it still, even like when you're at customer sites and whatnot, because you still have some downtime eventually. So, it's a little bit easier than like being at home where you like, you're expected to be home by between 5 and 6. Like I'm expected and
right.
then expected to help. So yeah, I would say just it changes over the years a little bit, but yeah, for sure. Like to really get a grasp on like using this control to a high level didn't I didn't sound like a fool in front of customers and whatnot. Like, yeah, it took me a good couple of years of struggling
Mm-hmm.
and spending a lot of time until my brain was tired. Like when your brain's tired,
Oh yeah.
when you're like, yeah, I don't want to do this anymore.
Uh-huh.
Like, I'm just done. Like, I don't want to do another example. I don't want to play with this anymore. Like, I'm done for the day. You can tell when you've exhausted that.
Oh yeah.
So sometimes you got to do that to get ahead. And then once you get to a certain level, then now you're just interested in advancing that and what else can I learn more? And so, yeah, that's kind of how I've evolved over the years now.
I love
think
it.
priorities is a big thing.
Yeah. All right. Last up, what is a thing that you have bought that really doesn't pencil out, but you wouldn't be without just for the reduced aggravation, fatigue, or aversion?
And what do they mean by like pencil out?
Like something that you've bought that like you can't make a good justification for. We've all bought those things that like, well, I don't really need it, but now that I have it, I would never be without it again.
Oh, I see. Yeah. Okay. So I would say a touch probe with, first of all, a touch probe. And second of all, a touch probe with collision protection. And if you can, even stylus collision protection.
Okay.
So a lot of touch probes out there. And so one of the unique things about if any touch probe that works with the Heidenhain control, as you probably know this, is whenever a touch probe goes into the Heidenhain control, that Heidenhain PLC is protecting that touch probe to some extent.
Yep.
If you have collision protection on the body, okay, that's something else we can talk about in a minute, but the stylus. So whenever you are using a Heidenhain probe and you're reeling that thing around with your hand wheel or you're jogging it with the jog buttons and you accidentally hit the part or you hit the fixture, you hit something in there, that probe, if you hit the stylus, that probe's going to stop right there dead in its tracks. And I always show this in my training. I turn the electronic hand wheel on, I jog it with the electronic, I say, go and flick it with your finger. And if I'm going at a little bit of a clip, you'll hear the drives grab it instantly and it stops. It's a hard stop. You can hear it. So that is fantastic. If you have if you have collision protection on your control, or if you have a collision protection on the probe, it's huge because it takes time to calibrate these things and set these things up. And, you want to put them in like a high precision mode that takes more time, so I show people how to calibrate it in like a base mode. And then I show people like a high precision mode where you warm the machine up and then you use a calibration tool with a Bloom laser. Then you measure a tool like what you were talking about earlier. You skim a surface and then you go and touch that surface with the touch probe. I call it like a high precision mode. That all takes time. So like if you hit these probes and you got to go and check it every time, that's just a lot of wasted energy. Now the official, Heidenhain Germany, where Heidenhain would officially say that anytime you hit the probe, like the stylus, you should always check it. Yeah. But like here in America, we don't always do that. So, we hit it up until a point, if I just grace it, like I'm okay.
Yeah.
And then as I continue to run this machine, as I continue to calibrate that probe, if I see that the stylus is going out by 6 or 8 tenths now, then yeah, it's like, all right, I'm going to refine the center and then I'm going to go dial it back in. Mm-hmm. Dude, it's funny because like with our touch probe, it's a 3-point. So it's not a push pull. It's like a 3-point balancer.
Yeah.
So it's difficult to do initially, but I've gotten the hang of it and I've only done it maybe like 10 times. And like the last time I did it, I spent like an hour on it. And then I got like, I don't know, like a 10th or 2 when I calibrated it. And I'm like, it's okay. So then I went back the next day. I spent another hour on it, worked on it, and then I calibrated it. And I got it like, it was like a micron or some crazy number, dude. And I'm using just like a tenths indicator. Like I don't even have like micron indicator. I think it's just a tenths. I just have a test, mm-hmm. a rapid test indicator. And I don't know how I got it that good. And the key is like when you on these Heidenhain probes, you just back that nut out or that little bolt in there. You back that screw out just a little bit just enough where you can move because there's a little coupling at the bottom that moves.
Mm-hmm.
You can tap that with your hand, or you could use a softer piece of metal like aluminum just to kind of move that around and then tighten it back a little bit. We're talking, like 1 or 2 hours on a clock. So I back it off like 1 or 2 hours on a clock and then I put it back. So I'm not moving it much. So I would say, yeah, collision protection on the stylus. And I think one of the best kept secrets in the industry is the Heidenhain has also a touch probe. So Heidenhain also makes touch probe. And the Heidenhain touch probe has an adapter. There's a coupling that goes in there between the spindle. So between the HSK holder and the probe is a coupling. And that coupling allows the probe to flex.
Oh, really?
So if that probe were to hit if that body of the probe were to hit a fixture or were to hit a part, the body would flex at that point and it would stop.
Interesting. Very
so
interesting.
Obviously, if you're rapiding, we have an issue. Okay.
Right.
But if you're navigating around in there, or you're going 200 inches a minute, 100 inches a minute, or you're moving around and you hit the body, man, that's fantastic too. You have collision protection built into the body of the touch probe. So I would say, yeah, that's one thing you just like, I can't really live without is like not having a touch probe and then the collision protection on there, because man, that just saves you in so many instances and it saves so much time and it increases your efficiency. There is, of course, right, people are hesitant because there's a training aspect of it, and there's, people can be clumsy. There's a experience level on that thing that you have to get accustomed to, and you have to take care of it. But that's for people to get training on. But once you treat that thing well, man, you're going to save so much time, because, you can set that thing up for automated setups, for measuring, inspection, and it's just great for just picking up a part like really quick. Not having to use an indicator, pick it up with the fixture or pick up the part. However you want to pick up your part or probe your fixture, you don't have to worry about tramming your fixture.
Right.
So yeah, I mean, that's one thing, like you really cannot live without, like when you have a high powered control or you have a 5-axis machine, like you need a touch probe in there, because that thing costs you a lot of money, and you don't want to be sitting there with your indicator for like 2 hours, trying to get the front, and then maybe you got to shim the part. Yeah, no way.
Yeah. Well, and on top of it, running kinematics and things like that is such a necessity to do high precision work. Like I wouldn't buy a machine without a probe now, but especially not a 5-axis.
Yeah. When you have these high-end controls, we have this kinematics opt, so you can find the center point of the rotary table, and you need a probe for that. And we're talking microns. So yeah, I mean, yeah, can you go into the parameters and like, can you go adjust that stuff? Yeah, you can. You can spend a lot of time and you can go back and forth, and then if you don't have a probe, then you're relying on a CMM, and so now you got that other aspect of it. So how are you going to true it up? Maybe you need a calibration tool. So you're looking at just a lot more involved if you don't have a touch probe to like find the center point of rotation.
Yeah.
Or you got to have a service company come in all the time, to like find your center point of rotation. Because, these machines go out, they warm up, they cool down. If they're not in a temperature controlled shop, man, they're going to go up and down a lot. If they're temperature controlled and you're doing, maybe not really high precision, maybe you're not hitting, like not needing to hold like 2 microns, then maybe you can go like a month. But if you got like high swings, like out by you in Arizona, where it's like, it gets really hot, and if you're not temperature controlled, yeah, you probably notice like yours, if you don't calibrate it like every week or every 2 weeks, that the machine will go out like 10, 20 more microns, right?
Yeah. I mean, we're lucky that our shop is temp controlled, but even then, good. Like you still notice a small difference running kinematics week to week and just making sure that everything's good. It's worth it.
Yeah. And like, especially when you have an investment like a 5-axis machine, you're all about efficiency and throughput, and using that 5-axis for automation. Like it's something you can't live without. So hopefully anybody who buys a 5-axis machine is buying some touch probe with it.
Totally. Well, Joe, thank you so much. Please let people know where they can find you online, or if they want to, reach out or have any questions, where can they reach out to?
So you can find me on LinkedIn, and so sometimes I'm posting places I'm at or things I'm doing. You can also reach out to me at Heidenhain. It would be just my first name, first initial, my first name. So J for Joe, Pizzoferrato at Heidenhain.com. Or you can reach out to us at our TNC application inbox, which would be tncapplications at Heidenhain.com. We also have if you call Heidenhain directly, you can ask for extension 3380, which will patch you through to our application line where you could leave a voicemail for us, and then we will get back to you on that. So yeah, those would be the three avenues you can get to. I'm not on LinkedIn a ton, but here and there you'll see me posting things. And yeah, I think it's a great way to connect and talk with people and see what's going on in the industry. I remember, we were trying to do this podcast with you since I saw you at the Hermela open house a year and a half ago.
Right.
Yeah, a year and a half ago. So like 2023. Then I ran into you at the Kern booth for the Insta Machinist. They were getting together for that group, and then we finally were able to make it happen. So that's really cool, and I do appreciate. Thanks for having me on.
Oh, it's my pleasure. Yeah, and thanks to all the listeners and all the Patreon members who make this show possible. Let me send people like Joe a mic and headset so you get good audio. Thank you all for listening, and I will be back next week.